Yeah. So what we discussed in the last class, we have started discussing about second law of thermodynamics. Okay. So where it will be dealing with spontaneity of a process. So what do we mean by spontaneous process? That should happen on its own, right now. That process has to happen on its own. Okay, like something like flow of water or anything in the nature, you can say all the process that is happening in the nature are considered as spontaneous. Naturally they are happening right now, right. So now when we want to decide the spontaneity of a process, whether a particular chemical reaction is spontaneous or not, it depends upon two factors. One is called entropy. One is what? Entropy change, delta S will indicate, and one more is called as enthalpy, that is delta H. Okay. So now a system is considered to be spontaneous by considering these two factors. So first factor is about energy. So first factor is energy. So now energy should be a system acquires minimum energy. Means minimum energy, whenever we are say a system is more stable, it means its energy will be minimum. More stability means it should have minimum energy. And one more thing here is okay, and one more here is maximum randomness. Okay, these are the two factors. Okay, so minimum energy means delta H has to be minimum energy, delta H has to be negative. What I am saying, delta H has to be negative. Maximum randomness means, see what I told you, any process happening naturally will be having more randomness. So just yesterday we discussed the flow of water. So what happens if water is splitting? So that is a naturally happening process. Now randomness of the water droplets will be more. Okay, if we want to collect them together, what happens in this case? They are arranged together, means systematically they are arranged. So randomness here is decreasing. So entropy is decreased in the second case, entropy is increased in the first case, that is splitting of water. So system will be acquired, like a natural process, a spontaneous process is considered, either it should have delta H negative, it means lower energy, or it should have a maximum randomness, it means entropy should be positive, greater than 0. So considering both factors delta H and delta S, we are discussing about this spontaneity of a process. Okay, now this can be explained through a special factor called delta G, Gibbs free energy. Okay, we will be discussing about that in this class. Okay, so now I just wanted to give you one more like clear cut idea again on entropy once again. Okay, so what is this entropy? I told you it's a measure of disorderness of a system. So more the disorderness, more is the entropy for that particular system. So now entropy, I am saying entropy is a state function. What I am saying is a state function. So now for a state function happening in cyclic process, if the process is happening in cyclic process, the entropy change, delta S change in cyclic process will be 0. Anything, any state function, if it is operating in the cyclic process, then total change, the net change here will be 0. Okay, this is integration of, it means total change in the cyclic process will be 0. Okay, consider, take this as an important point. And next, so delta S total means, see what we have when I say thermodynamic system, so there is something called system and there is something called surroundings. Okay, together we are saying it as a universe right now. So delta S total, that is nothing but delta S universe equals to delta S system plus delta S surrounding. Can I write like this? Delta S system plus delta S surroundings. Okay, so now for a spontaneous process, what I am saying, delta S total should be positive. Okay, next, and this is for cyclic process, it should be 0. Okay, if this is 0, then I can say delta S system will be equals to minus of delta S surrounding. Can we take it like this? If the process is in cyclic process, the total change will be 0. So you can write it like this. Yeah, next. Mathematical equation what I have given yesterday, delta S is equals to dq by ds equals to dq by t. Okay, so now here you can take dq means what is the first law of thermodynamics we have. So du equals to dq plus dw we have right now. So from this is the first law of thermodynamics. From this dq is equals to du minus dw we can write. Okay, so here you can take du minus dw by t. This is what ds. Okay, so now here we have one more equation like du equals to cv dt. Okay, and what about dw? This is minus pd. Okay, take these two values over here. So I can write du in the place of du as cv dt by t minus dw means minus pdv. Minus of minus I can write plus p dv by t here. Okay, so now here this is cv 1 by t dt here we have plus pv equals to RT I can write for ideal gas equation from ideal gas. So p by t means R by V also I can write. Okay, so please look at here screen, whenever it is blurred you just tell me. Okay, yeah, so here p by t means R by V we can write. So here I can write R by V dV, that is what ds. So apply integration on both sides. So from S1 to S2 and here T1 to T2 and here V1 to V2. Okay, so here R is a constant, here I can write 1 by V dV like this. Okay, so now upon integration what is the formula we will get here? So delta S, that is S2 minus S1 equals to CV, one integration of 1 by x dx ln x we can write. Okay, so here ln x, what is the upper limit and lower limit? T1 and T2. So that we will get CV ln T2 by T1 plus R ln V2 by V1 will get. So this is the equation we got here. Okay, so now if I say isothermal process delta ST, so what you are going to get here? Isothermal process, if I say what is constant here? Isothermal means temperature is constant. It means temperature constant means T2 and T1 are equal. Therefore this whole term becomes what? This one will be cancelled out. So ln of 1 will be 0, log 1 ln 1 will be 0. So this first term becomes 0, then you will be having R ln V2 by V1. Okay, or you can say delta ST equals to 2.303 R log V2 by V1. Okay, and similarly if I say at constant volume delta SV if I ask, so what is constant here? When I say SV is a constant means this term will become, the second term becomes 0. Okay, if this is becomes 0, so we have CV ln T2 by T1. So this will be the formula when they are asking in entropy change in isochoric process. Okay, so these final formulas are important. These formulas are important. Okay, now I will show you some other important formulas that we can get as similar to this. See, now I have given in terms of isothermal process and isochoric process. By changing this PV terms, so we can also get isobaric and like isobaric we will get in this format. Okay, so now what about adiabatic means? Adiabatic process means what is constant here? Q is constant. So change in Q will be 0. So it means ds will be dq by T we are writing now. So dq 0 means entropy change also 0. Okay, so for adiabatic process in reversible process it will be adiabatic reversible process entropy change will be 0 because its heat change will be 0, that's why entropy change also 0. Okay, and after this, right. After this, see, we have phase transition from solid to liquid to gas like this. Okay, so now whatever the enthalpy change here we are representing with a delta H, and what is this process? Fusion. Solid to liquid it is fusion, and liquid to gas delta H vaporization, and this is what? Delta H sublimation. Okay, these things we discussed yesterday. Now entropy during the entropy change during this like this phase transition can be considered as, see, if I want delta S vaporization, so what you should take? Delta H vaporization by T, like whatever the temperature we have used here during the process. Okay, and if I ask for delta S sublimation, this is delta H sublimation here, sorry, delta H vaporization. So this is delta H vaporization. So what this liquid to gas conversion is what? That is boiling point. Now at boiling point it will be taking. So temperature you should take as T boiling, you can say. If I ask for delta S fusion, what is your formula? Delta H fusion by T melting. So whatever the temperature here you are taking, that will be considered here in the formula. Okay, delta HF by T melting. Okay, like this. Next. Okay, now tell me in which can change the entropy is negative. In which of these following entropy change is negative? See, they have told evaporation of water. It means water liquid is converting into gas right now, so vapors. So now what happens here? In which physical state we have more randomness? Particles will move freely in which state? Gaseous state. So entropy change in the first process is what? Positive. Delta S is positive here. Why? Gaseous have more randomness than the liquid, so it will be positive. Now they are asking about negative. Expansion of a gas at constant temperature. Okay, expansion now, that is also positive you can consider. So sublimation of solid into gas. So what about this? Positive. What about this? See here, gas is converting into gas, its physical state is fine, but here how many gas particles are there? 2, but here it is becoming 1. So now 1 minus products minus reactants, what we are getting? Minus 1. So it means entropy is negative in which case? In the fourth case. Is this clear or not? During a chemical reaction, you just find delta Ng. Delta Ng means gaseous products minus gaseous reactants. If it is a negative value, then it will be having a negative entropy. Entropy decreases during that process. Okay, right. For example, formation of ammonia. Tell me entropy, what happens during that process? Formation of ammonia means from where it will forms? N2 plus 3H2 gives rise to 2NH3. During this process what happens? The entropy change. All of them are gases. Entropy increases or decreases? So just simple one, what I told you. So take products minus gaseous reactants. So it will be minus 2 means entropy decreases. So delta S is negative or less than 0, you can say like this. Okay, next. Tell me answer for this question. Calculate entropy change when 2.8 grams of N2 gas expands isothermally and reversibly from an initial volume of 1 liter to final volume 10 liters at 27 degrees Celsius. Find it once. So how can you do this? What is your answer here? Joules. So you should take R value which gives in joules. What is that? 8.314 joule per Kelvin per mole. Okay, so delta S. See, how can you do this? At constant temperature, how much it is? 27 degrees. Okay, so delta ST, isothermal process it is. So what is the formula we have? NR log NR ln V2 by V1 I have given. Okay, or you can take 2.303 into N. How much N here? So they have given 2.8 grams now. So how many moles you calculate first? So 2.8 divided by what is its molar mass for nitrogen? It will be N2 means 28. Okay, and R value you should take 8.314 as it is a constant. Okay, so into log V2 is how much? 10 by 1. So log 10 here it is 1. So here it is 0.1. Okay, so 8.314 into 0.1 into 2.303. So 2.303, 8.314 gives 19.1 into 0.1 joules. Okay, so what is your answer here? Joule per Kelvin. See, so this will be 1.91 joule per Kelvin. So where do we have? Second option. Okay, so do not ignore this N here. Okay, so N given amount of substance they have given, consider from there. Okay, so if I ask same question by giving 28 grams, what is your answer? 28 grams of nitrogen is given. So just take here, it will be 1. So it will be 19.1 joule per Kelvin. So be conscious what is the amount they have given here. Okay, now try this. If the enthalpy of vaporization of water is given at its boiling point, then the entropy of its vaporization at boiling point will be. So what is the formula we can use here? Tell me. See, water. So water they are saying now, what is its boiling point? 100 degrees. So 100 degrees Celsius means convert this into Kelvin. So 373 Kelvin you have. And what they are asking, entropy change. Delta S vaporization is what? What is the formula I have told you? Delta S vaporization equals to enthalpy of vaporization, delta H vaporization by T. Okay, so what we required here? Entropy. So substitute delta H vaporization given is here this much. Okay, and divided by this thing. So you will get one of these options. Okay, so yeah, so 186.5 kilojoule by 373 kilocalorie. Okay, Kelvin. So this will be around 2 times. Okay, so 0.5 kilojoule per Kelvin will be your answer. First option. Okay, next. This is already done. This one you can also just simple now. Next, Gibbs free energy. So at the beginning of the session what I told you, there are 2 terms to decide spontaneity of a process. One is delta H, another one is delta S. Okay, considering these 2 we have a new term called G, Gibbs free energy. Okay, so we are studying about Gibbs free energy now. energy. It's also a state function and extensive property. Okay, so G is equals to H minus Ts. Okay, where H is enthalpy, T is temperature in kelvins, and S is entropy. Now see, these are the two factors we should consider. So combining both of them, we have a new factor called G here. Okay, which says about spontaneity of a particular reaction or a particular system. So now consider delta G. If I want to derivate this, what happens here also? dG I am writing here. You can write this as dH minus dTs. Like this we can write. So this apply UV formula here, dH minus TdS minus S dt you should write. Okay, first keep a constant, keep one constant, derivate the second one. Again keep the second one constant, derivate this one. So UV formula. Okay, next here if I say temperature is constant here, temperature is constant, what happens to the equation, tell me? So dG equals to dH, what is constant? Temperature. So this term becomes what? dt, so it will become 0. So TdS. Okay, so dG equals to dH minus TdS. Okay, or I can say delta G equals to delta H minus T delta S. Okay, so this is a formula that will be utilized or used for expressing a spontaneity of a process or predicting the spontaneity of a process. Okay, for a spontaneous process delta G must be negative. What I am saying, delta G has to be negative. Okay, so in order to make this negative, what are the ways you have? So delta H may be positive and delta S may be also positive, or delta H may be negative, or this can also be positive, or it can be negative, this can be positive. Like this we have different possibilities now. So write all the 4 possibilities and we will discuss one by one, and it can be negative, this can also be negative. These are the 4 possibilities we have. Okay, so first case, what happens if both of them are positive? What happens to the equation? Tell me, what happens to the equation? So when it will become a spontaneous?
When both are
see here, what is the condition I told you? Delta G has to be negative. In order to make this negative, what are the ways here? So delta H is positive. See, first term is positive. Here already negative symbol is there. This is positive. Positive into negative here, negative only. Okay, but first term is positive and second term completely it is becoming a negative. So in order to make this negative, which term has to be greater here? Second term has to be greater than the first term. Then delta G become negative. So in order to make that, so delta H by delta S should be less than T. Therefore the whole term becomes negative. Okay, so it means delta H by delta S, if less than T, then process becomes spontaneous. Okay, so T has to be greater now, so I can say high temperature. At high temperature process is spontaneous. If it is at low temperature, that will be non-spontaneous. Okay, next, what about this condition? Just try to apply here. See, second term is negative, here this is negative and already negative sign is there, delta S is positive. So both are becoming what? See, this is also becoming negative. So completely whole term becoming negative. So delta S is negative here. So I can say this is spontaneous at all temperatures, but the previous one is spontaneous at only at a high temperature. Now consider this and tell me, first term is positive, delta H is positive and minus we have delta S is also, here it is negative. Negative into negative becomes positive. So whole term becoming what? Positive. So delta G becoming what now? Positive. So positive means it is a non-spontaneous. So I can say this is non-spontaneous at all temperatures. It is non-spontaneous at all temperature. Now next tell me for this, first term is negative, delta, this is negative, and here we have negative, but this is also negative. So it means first term has to be greater. Okay, it means delta H by delta S should be greater than T. Okay, so delta H by delta S should be greater than T, then the process becomes spontaneous. Okay, so it becomes spontaneous at this particular condition. So temperature should be less now, so I can write low temperature. So at low temperature the process will be spontaneous. Is this clear or not, how we are able to discuss, decide whether a process is spontaneous or not? Yeah. So now look at these questions. Answer this question once. Yeah, I will show you. First you answer these questions. Impossible means non-spontaneous here. Okay. A reaction is impossible if tell me, a reaction is impossible if delta H is positive and delta S is
negative.
See, if already negative, again negative, it means total term becoming positive. So delta G becoming positive, it means this is the case where it is impossible. Right now, non-spontaneous at all temperatures. Okay, so now you are asking me something. This one. Okay. Next. Okay, now I will give you 1 or 2 questions, just tell me answer for them. Write the question. For a reaction A plus B gives rise to C at 500 degrees Celsius, or otherwise take it as 300 degrees, 300 Kelvin. Shows non-spontaneous at options delta H 200 kilojoule per mole and delta S -4 joule per Kelvin per mole. Okay, first. Second option, this is delta S. Okay, and second option -200 delta S is -4 joule per Kelvin. So tell me whether is it spontaneous or non spontaneous in the first case? Spontaneous.
minus 1000.
See, what about delta G for a spontaneous process? It should be negative. Okay, so tell me, look at the values whether it makes positive or negative. See, delta G means delta H minus T delta S na. Okay, so what about delta H? It is positive here. Okay, minus, and delta S is given as negative. So negative into positive, negative into negative here becomes positive. So overall term, all the term becoming what? Positive. So it is positive means non-spontaneous. So out of these two, it is impossible at first condition. It is impossible or non-spontaneous at first conditions. In the second condition, you check. So you need to check this one by considering with comparing with the temperature. See, delta H is given as negative and this second term is positive. Okay, now which is should be dominating? Delta H by delta S has to be greater than temperature, then only it will be considered. Okay, now tell me here delta S H is how much? Minus 200 and here it is 4. Okay, so it means here this will be how many times? What is the question they have given? 4. Okay, so it will be 50 kilo. So this will be 1000 here, kilo means. Okay, so it will be becoming how much? So this much. So definitely greater than that value. It means spontaneous in the second case, non-spontaneous in the first case. Okay, so what to do? Just compare the given values with the temperature and you can decide. Okay, one more question you write.
So both are non-spontaneous?
No, first condition is non-spontaneous, second is spontaneous. No? Okay, next, write the question. Delta H is 30. Delta H is 30 kilojoules. Kilojoule per mole. And delta S is 60 joule per Kelvin. Per Kelvin per mole. Okay, tell me. So at what temperature the reaction will be spontaneous? At what temperature reaction will be spontaneous? So tell me, at what temperature it is spontaneous? Tell me. So what to do? So you just compare this H minus T delta S. No? So put these values over here and get the proper relation. Okay, so it is positive. Here this is positive. So second term becoming, this second term becoming negative here, first term is positive. So which term has to dominate now in order to make this negative? Second term has to be dominating. It means delta H by delta S should be less than temperature. Okay, so here what is the value they have given? 30 into 1000 joule we can write, and here 60 joule per Kelvin per mole is given. Okay, so here it will be 2 times. How much here? 500 Kelvin we got. So it means temperature above 500 Kelvin reaction will be spontaneous. Okay, above this temperature. So they may not give it is in Kelvins now, they will convert this into degrees also. So how can you do that? Minus 273. Okay, yeah, this is about the thing. Next, delta G, we have this relation now we got up to here we have studied. Now next one is delta G and temperature relation here. Delta G equals to RT ln Q plus delta G naught. This is one more relation here we have. So at equilibrium delta G will be 0. What is 0 here? Delta G will be 0. Then delta G naught will be equals to minus RT ln K. Okay, wherever we have Q, I am considering it as K here. So about Q and K we will study in the next chapter, equilibrium chapter. Q means reaction quotient, K means equilibrium constant. Okay, so what about delta G naught? This is standard, this is Gibbs free energy change I am saying, this is standard Gibbs free energy. Okay, so relating like this, now K means equilibrium constant I am saying. So if I want to get K equilibrium value, what I should do? Delta G naught, and I can send this here, becomes RT minus here, and if it comes here it becomes exponential. Okay, next. If I want in terms of log, you can write K equilibrium equals to 10 power minus delta G naught by 2.303 RT. Okay, these two are important again. Write that final equation. Okay, write one question. For a reaction delta G naught is equals to minus 10. Minus 10. Then K equilibrium is how much? So what happens here? If this is minus 10, so it will be written as K equilibrium will be e power minus 10 by RT. If they give any temperature value, substitute over here to get the final answer. Okay. So now one more thing they will ask like this. See, A plus B gives rise to some C they will say. Okay. So delta G naught of reaction they will ask. Okay. By giving formation delta G naught of formation of A is some like X and something like for B Y, and for G naught of C will be some Z value they will give. Formations they given now. So what is forming in the reaction here? C is forming. Okay. So if it is 1, so delta G naught of reaction will be written as, so 1 into what is its value? Forming, C is forming now. So how much it is? Z minus, these are deforming now. So here it will be minus X plus Y. Okay, you can write Z minus X minus Y like this also. Okay, if there is a coefficient here, instead of 1, let us say I have some 2. What you should take now? Multiply this Z with 2. Okay, like that. Okay, so again, so we have two types of reactions now, exothermic and endothermic. So see here in endothermic process, so product energy will be greater than the reactant energy. See here we have reaction coordinates, like this is a reaction, this is a energy profile. Okay, so now energy of reactant, if R is giving some products P, so energy of reactant here and product energy is here. So the difference here we are calling it as enthalpy. What is the delta H? means enthalpy of products minus energy of products minus reactant. So what about this term here? What do you call this one? See, here is a reactant, starting material energy is this much. In order to make this reaction happen, this much amount of energy is still more required for the reactant. So that is what we call it as activation energy. Okay, EA, activation energy. Okay, so next, for exothermic reaction, product energy will be lower than the reactant. Okay. Next, we have one more third law of thermodynamics. So what it says, the absolute entropy of a perfectly crystalline substance at absolute zero will be 0. Absolute temperature means 0 degrees, 0 Kelvin will be 0. Okay, remember this like direct statement, that will be useful. Okay, next, write few questions. Write a question. If the entropy of vaporization is 110 joule per Kelvin per mole and enthalpy of vaporization 50 kilojoule per mole, then the boiling point of the liquid is, what is the entropy? 110 and enthalpy 50 kilojoule, then boiling point. Okay, so you do that. I will write one more question on the board, so you can try this after that. The heat of combustion of methane given CH4 so is to CO2 plus H2O. Given CH, bond energy as 414, 499, and C double bond O 724, and OH bond as 460. Okay, this is the data they will provide in the exam. So you need to find enthalpy change or heat of combustion of this reaction. So delta Hc of reaction, how we will do this? What is undergoing combustion? Here methane is undergoing combustion now. Okay, so how many bonds are there? Like this 4 are there. So it means 4 into like bond energy of reactants minus bond energy of products we should consider. Okay, so how many bonds are there for carbon here? 4. So 4 into CH. Okay, each CH energy is 414, substitute there, plus, and here 2 oxygens are there, oxygen molecules are there, 2 into oxygen like this. Okay, minus here, what about CO bonds? How many are there? CO2 means there will be 2 CO bonds right now. So 2 into CO plus this type of bonds are how many are there? 2. So 2 into OH. Okay, so substitute the values, you will get the answer. Okay, right. So write one more question. One mole of an ideal gas, 1 mole of an ideal gas at 0 degrees and 1 atm absorbs X calorie of energy, X calorie of energy, and expands to 224 liters. Under isothermal reversible condition. Calculate X.
So what is initial volume? Initial volume.
So this is what you need to think. Once again read the question. 1 mole of ideal gas at 0 degrees and 1 atm. So 0 degrees and 1 atm is nothing but STP condition na? STP condition. 1 mole of any gas occupies how much volume? 22.4 liters. Okay, from here it is expanding to 22.4 liters. So it is becoming almost 10 times. So log 10 becomes 1 here. It means V2 by V1 becomes 10. So log 10 1. Okay, so multiply the remaining things. Okay, that's it. So write one more question. For a reversible expansion of 1 mole of ideal gas from a volume of 10 liters to 20 liters at 27 degrees Celsius, calculate work done, expansion of work done by the system, heat absorbed by the system, okay, and entropy of the system, entropy change for the system. So these 3 values I want. Okay, so try these 2 questions. That's it about the session. And if you have any doubts in thermodynamics, you can ask me by practicing some questions.